So today I'm going to be talking about polynomial functions, basically what they are, um, some characteristics of them, I'm going to be talking about like end behavior and really, most of this is just going to be talking about end behavior of polynomial functions. So let's start first of all with, so you might have learned before, polynomial just means like multiple terms or variables. So like y equals x squared. That's a polynomial. Um, if we have y equals x to the power of 12 plus x to the power of 23 plus x to the power of 27 plus 8, that's a polynomial. You can even have fractions too, well, not in the exponent. You can't have fractions in the exponent, but y equals x to the power 14 divided by 3 plus 9 over 2. But some polynomial functions, okay, well, no. This is what can't be a polynomial function. Let me just put like an x. So what can't be a polynomial function is some examples like y equals root x. Reason for this is root x is basically y equals x to the power of 1 over 2, right? And that's that's um that's a fraction, and polynomials, their exponents always have to be non-negative integers. So yeah, that also means like you can't have y equals x to the power of 0.5. And these are all the same thing. This is just another way of writing it. Another one that can't be a polynomial is y equals 5 to the power of x, because obviously this is not a polynomial function, this is an exponential function. So another characteristics of polynomial functions is it has to have x raised to some like non-negative integer. So this would not be a polynomial function. Stuff like y equals sine x, because that's a sinusoidal function. Also, yeah, so can't have negative as the exponent, because this would just kind of be like y equals 1 over x, right? Because this simplified is just going to be y equals 1 over x to the power of 14. And we can't have that. That's not a polynomial function. But so let me talk about some wait. Okay, so this is something you need to recognize if you're like looking at polynomial functions. So before you go into before I go into like end behavior and like how the exponents, if it's like odd or even, so I just want to let you know. So if we start with this function, right, y equals x, we know this is a linear function. It's gonna look like, just trying to make this, it's gonna look something like that, right? It's gonna be x is gonna go to infinity, and fx is also going to infinity, while x goes to negative infinity. Um, fx is also going to negative infinity, and we can just imagine like this is just x, but with like a invisible 1 as the exponent. And we know that a quadratic, y equals x squared, um, like that, the end behavior is going to be the same. Because why? Um because it's squared, right? So this is what a parabola usually looks like. And the end behavior is the same. As x goes to infinity, fx goes to infinity, and as x goes to negative infinity, fx is still going to go to infinity because it's going up, right? So now let's look at cubed. Y equals x cubed. It will look something um like that, right? And what can you notice about a linear function and cubic function? Well, first of all, these are going to have the same end behavior. So look, it's going to be x goes to infinity, fx goes to fx goes to infinity as well. As x goes to negative infinity, fx is also going to go to negative infinity. And you're going to start to see a pattern with odd and even exponents for the functions. See how when it's odd, it's going to have this end behavior, but when it's even, so let me just give you an example. If we have x to the power 4, we can imagine it's going to look something like this, but um maybe like slightly different, like something like that instead. But we know if we know the end behavior, it makes it really easy to predict how the function's going to look like. And this is going to help us a lot when we're dealing with polynomial functions with like multiple coefficients and exponents. So yeah, this end behavior is gonna be the same as x goes to infinity. Fx goes to infinity, and as x goes to negative infinity, fx goes to infinity. So now if we look at just let me just write this down. So all odd functions, so all odd functions that, by the way, don't forgot to mention that if there's a negative, of course it's going to be flipped, so it would go it would go this way instead, and the end behavior would flip. Goes for this one too, would go down like that. This one could go like this. But basically, a general thing you need to know is all odd functions, their end behavior is most with no coefficient. See how there's like no number here? Just like a invisible one. Wait. So with no coefficient, which is the number in front of the x or variable, coefficient. Um, so yeah, that usually their end behavior is gonna look like as x go. They're gonna have the same end behavior, but usually gonna have as x goes to infinity, gonna go to infinity. As x goes to negative infinity, fx goes to negative infinity, right? And even functions, they're gonna usually look like again with no coefficient. Oh yeah, and also not negative, no negative sign. But usually the end behavior is still gonna be relatively the same. It's usually just gonna be um yeah, the end behavior is gonna be the same on both sides. So as x goes to infinity, function goes to infinity. Say that's on like the right side. And then as x goes to negative infinity, yeah, as x goes to negative infinity, function's gonna go to infinity. Obviously, if this flips, if it instead of it looking like their parabola, um this is what the normal parabola looks like, right? So when a is greater than 0. But if we have like this, a is less than 0. Obviously, both fx is going to go to negative infinity. Well, as x goes to infinity, fx can go negative infinity. As x goes to negative infinity, fx is going to go also to negative infinity. So basically, if it's vertically reflected and a is less than 0, it's gonna basically these are gonna flip. But this is just a general thing you should know about odd functions and even functions, their exponent. So now I want to get into so now after I explained all of that, I just want to show you something. So let's say we're given a polynomial function, right? Y is equal to negative 9x to the power of 7 plus 8x to the power of 4 um minus 3x plus 8. So if we're given this polynomial function and we want to like know the end behavior of it, so we're trying to find the end behavior and also generally how it's going to kind of look like, because the end behavior kind of tells us how it's going to look like. What we're going to have to do is we're going to have to look at something called the leading coefficient. And what is that? So basically it's it's the coefficient of the x that has the highest power. So in here, which one do you think would be the leading coefficient? Um, Give me a sec. So highest power. Obviously, it's going to be negative 9 because x to the power 7, x to the power 4, x to the power 1. This is the highest power. And that's what we use to determine the end behavior of a polynomial. So negative 9x, there's a negative, so it is going to be vertically reflected over the x-axis. So now we know, and this is an odd number. So what we can gather from all that information is that the graph is going to look something like this. Obviously, this is not going to have precise, it's not going to have accurate turning points because we're just predicting on how it looks from the end behavior here. But since it's an odd number, we know that usually it would it would look something like this, right? But we have a negative, so what it's actually going to look like is like this, something like that. This part here is not accurate because obviously it's gonna be like it's gonna look way different actually. But we know the end behavior, and we can say that the end behavior for this one is as x goes to negative infinity, function goes to infinity, and as x goes to infinity, function goes to negative infinity. Because fx is like the y value in this case, right? This is what I'm referencing every time I say fx. And that's the way we can tell. So that's the leading coefficient, the one with the highest power. So let me just give you one more example. Okay, so let me give you a different one. Let's say we have y equals um 6x to the power of 27 plus 8x to the power of 9 plus 2x to the power of 43 plus 17. And this is in standard form. Actually, I don't need to write that. But what do you think here is the leading coefficient? From looking at it. So the obvious answer here, people might think it's like 6x27 just because it's in front, but that's actually not the case. It is going to be 2x to the power of 43 here, just 2, because we're just looking at the coefficient, right? So because 43 is the highest power here out of 9 and 27. So what we can say about the end behavior of this polynomial function is that it will probably be something like well, this is odd number again, so wait, let me just turn this into an even number actually, just to show you what a even number one will look like. So even number, coefficients 2, um, yeah, in this case it doesn't really matter unless there's a negative, so we're just gonna draw it like usual. It's gonna look something like that. Obviously there's gonna be like some stuff going on here that we kind of disregard because we're just looking at the end behavior. So it's not gonna exactly look like this. This is inaccurate. Obviously there's a vertical stretch too, but what we can say about the end behavior for this polynomial function then is that as x goes to infinity, x goes to infinity, as x goes to negative infinity, x still goes to infinity. And let's say it was just like reflected, right? We add a negative, it would look something like this. I just put the squiggles there because there's gonna be like, it's not gonna look exactly like that. But the end behavior now, it's gonna be like x as x goes to infinity, fx goes to negative infinity, as x goes to negative infinity, fx also goes to negative infinity. So it's just basically this one but flipped because of the negative sign. That's basically what that means, right? Vertical reflection. It's just flipping the graph over the x-axis. So that's introduction to polynomial functions. Might make another video on this because I think it's pretty easy, but I think it's easy to explain. But if you enjoy this, please subscribe or like the video. It would help me a lot. I would really appreciate it if you do. Um, and yeah, that's all. So thank you for watching. See you in the next one.